Okay guys, so since we've finished discussing all about the introduction to heat transfer, basically the heat transfer mechanisms, conduction, convection, and radiation. So ngayon naman, we'll be discussing all about unit operations. And we have three in line with this, which are the heat exchangers. And by the way, heat exchanger is actually the equipment and not the unit operation itself. Then we have evaporation and then crystallization. So in this midterm, we'll be focusing on those three unit operations or unit process that very essential in learning chemical engineering. So let's talk about this heat exchanger first. Okay, so heat exchanger is an equipment again. So hindi siya specific na unit operation, but it is employed in many industrial companies para ma-change natin yung temperature ng fluid natin na kailangan natin. So for example, medyo mataas yung fluid inlet, kailangan natin siyang ibaba. So we're using heat exchangers to do that. These heat exchangers can be either double pipe, shell and tube, or cross flow. So meron tayong tatlong major types of heat exchangers. So the first one is the double pipe, or ito yung pinaka-basic natin na heat exchanger. So imagine if you have something like pipe here, and then yung fluid, so may isa pang pipe, then ganyan, parang pangit. Basta. So, imagine meron kayong dalawang pipe na concentric siya. So, yung fluid papasok dun sa pinaka-loob na pipe. And then, yung pinaka-fluid dun sa inside na yun, ikukulo siya nung fluid na dadaan mula dun sa side. Pero, in contact siya ngayon dun sa surface nung tube na nasa inside. So, basically, wala silang direct contact yung dalawang fluids na yun. But, nangyayari is kakaroon ng heat transfer due to combined conduction and convection. Kaya, yung atin na driving force with that, diba, we usually give this as Q equals UA delta, HA delta T, knowing na yung H natin is the convective heat transfer. But in this case, actually, medyo umuulan na. So, anyway, so yung H natin, this becomes a combination of conduction and convection. So yung radiation na, neglect na natin yon. So, ang nangyayari is combined conduction and convection, which equates to the overall heat transfer coefficient. We can also refer to this as the outside or the inside overall heat transfer coefficient depending on the case. Kung binigay sa inyo, for example, is outside area, then you'll be using the outside heat transfer coefficient or overall heat transfer coefficient. But if it's on the inside area, then you'll be using the overall inside heat transfer coefficient. Some problems will not specify if it's either outside or inside. So in that case, just use, let's say, A or U for such cases, right? And of course, I'll be giving you problems so that you can understand how this scenario works. Okay. And then, knowing those three major types of our heat exchangers, for the double pipe, we have a countercurrent flow and then the co-current or the parallel flow. So, dalawa lang sila. And imagine meron kayong yung dalawang pipe natin na hindi natin may diretso dito. So, but the thing is, siguro mag-attach lang picture dito. So, meron tayong dalawang pipes right there. And then, if the first fluid on, let's say on the inside, flows right here. So, from this right going to left. So, hindi ko alam kung ganyan yung nakikita mo sa video. But, from right to left. So, yung papasok na fluid on the side would go from left to right. So, kaya nagkakaroon tayo ng countercurrent flow. Basically kasi, the flow is opposite with each other. Now, parallel flow would have the same direction. So, kung halimbawa yung ating fluid on the inside flows from left to right, then yung ating side natin na fluid would flow from right to left then. Sabi ko ba right? Basta, same direction lang sila. Instead of having countercurrent, which is napaka-practical naman sabihin na sila is opposite. So, ganun lang, they have the same direction. So, ang fluids natin, they can be cooled or heated depending dun sa kailangan natin gawin ng heat exchanger natin. So, it's vice versa kung ano ba yung goal mo is gagawin siya ng heat exchanger. But usually, we let the hotter fluid on the inside of the tube and then yung colder fluid natin on the outside of that para lumamig yung ating fluid on the inside, leaving the colder fluid on the outside having higher temperature than its initial temperature. Okay? So the next type would be the shell and tube heat exchanger. So itong shell and tube heat exchanger, they're mostly employed in industrial practices na mas maliit yung capacity. Kasi basically yung requirement niya is medyo mas laking construction. So, and then maraming tubes na kailangan. So, hindi talaga siya practical gamitin sa malaking industrial application. But for those small scale na mga processes, so ginagamit siya. Ang kaibahan naman nito sa double pipe is that from the word itself, shell and tube, meron siyang shell, parang yun yung kanyang, 'di ba, shell parang bahayan tawag natin. So, yung parang bahayan na yon, nandun lahat yung mga tube sa loob nun. So, it can be multi-tube and usually it's multi-tube. So, mangyayari doon, marami siyang tube and then depende sa arrangement niya kung ano yung magiging flow ng ating heat exchanger. And usually, we employ what we call this correction factor or FT to solve for the capacity or the heat capacity of this heat exchanger. So, later on sa problem, mas mag-guess siya kung paano natin ginagamit yung correction factor and bakit ba nawawala siya usually when we talk about double pipe heat exchanger. And the last one would be the cross flow. So, pag sinabi natin cross flow, instead of having counter current or parallel, the cross flow heat exchanger would employ a perpendicular flow of the fluid. So, for example, if the fluid or the hot fluid flows from left to right, so the perpendicular colder fluid would flow, yun, basta ipa-perpendicular niya tong flow ng fluid na yun. Pero remember, wala silang direct contact. They have a boundary lagi, which is separated usually by the material of construction, depende kung ano ba yung fluid na ginagamit natin. So usually naman, water is used to cool or to heat yung ating mga fluids. But sometimes it's different depending on the situation. There is still what we call a contact heat exchanger. Ito yung technical nagkakaroon ng contact talaga sa fluids. But they are usually employed in very rare cases wherein we use gas to have contact, inert gases. Kasi, diba, kung siya inert gases, wala silang reaction dun sa ating fluid. So, basically, okay lang siya magkaroon ng contact. But, most of the time, and almost more than 70% of the industries they employ this kind of heat exchanger wherein there is no direct contact with the fluid because bakit mo ba kakaroon ng contact? For example, if you have, let's say, sugar solution and then kinontak mo siya sa water, then therefore yung concentration may sumabawasan basically because the water is mixing with the sugar solution. And to check on that, we usually use or check the purity of our fluid para malaman natin if kung nakakaroon ng leak during the heat exchange na nangyayari during the process. Okay? And as I go on with the discussions, I'll be discussing something about this mean temperature difference, which is very important in talking about heat exchangers. Kasi itong mean temperature difference, ito yung magdidikta sa atin kung ano ba talaga yung magiging difference natin na temperature na gagamitin para makuha yung ating overall heat or energy na required for the heat exchanger. So, ayun, and then I will also talk about this the capacity and then the effectiveness of this heat exchanger once now we discuss all about the problems. Okay, so with that, let's try to solve a problem that's involving these heat exchangers. Okay. Okay, so as promised, here is an example or a problem regarding heat exchanger. So, kagaya ng ating mga process ng solving for heat transfer, the very first process in solving any unit operation problem or let's say heat exchanger problem is by identifying the condition. So, pag sinabi natin condition, kung ano ba yung type ng heat exchanger na ginamit and the flow of the fluids. In this case, we have a double pipe. So it is a double pipe, and then the flow of the fluid is countercurrent. So ibig sabihin nito, magka-opposite yung direction ng ating fluid flow. So if for example, meron tayo ditong tube, then the hot fluid comes in, and then at the annular region or the side for this particular arrangement would be that the hot fluid or the colder fluid will flow to this direction. Okay, so just to emphasize this, bali ito yung ating boundary dito. Ito yung mga pipes natin. Okay, and then ito yung region for the other one. So in this problem, let's identify the given. So meron tayong fluid na nag-enter on the inside, which is water yon. And then yung polymer fluid natin na nagkakos para yung ating hot water flowing inside will cool down, flows on the annular space between these two pipes. So in short, if we have hot fluid that flows inside the tube, we have THI. So that is the hot fluid that flows inside, and that is equal to 90 degrees Celsius. And then this polymer enters at a temperature of 10 degrees Celsius. So that's our cold inlet. So that's TCI, and that is 10 degrees Celsius. Now then, this hot fluid will cool down to 60 degrees Celsius. So we have THO, and that's 60 degrees Celsius. Now, pag check niyo yung Paris Handbook and other references, they use different notations for these temperatures. But the idea here is just to represent any of that by taking T1 and T2 or capital T, capital T for the outlet. Basta identify nyo siya as inlet and outlet. Okay? And then the last one for the cold outlet. So ito, pumasok siya ng malamig. So syempre, iinit din yan. So that's 50 degrees Celsius. So basically, these are the temperatures of our fluids. Now, if we would like to represent that in a certain temperature profile, so we know that this is the flow of our TH. So, diba, ito yung inlet, and then it goes down. So, ito yung THO. And then, yung cold inlet natin, so since countercurrent siya, so the movement is something like this. Okay? So, in that case, this is TCI, and then TCO for here. So, we know that this is a countercurrent. And remember, kapag countercurrent yung ating temperature profile, mas kung mapapansin nyo, medyo halos nagpapantay na yung ating differences in the temperature. But the idea is just to look at the arrow, and then doon natin masasabi kung siya ba ay countercurrent or co-current. And then, yung ating temperature difference na laging hinahanap is hindi itong HI and then HO, kundi ito, that's the same side ng ating nasa same side ng ating equipment. So, for example, meron tayong kasi pagka double pipe and then countercurrent siya, ang magkasama na temperature profile or malapit sa isa't isa by virtue of their distance would be the inlet ng pipe and then yung outlet ng cold fluid or dun sa shell. Hindi naman shell, basta yung parang other pipe dun sa annular region. So, that is our delta T1, and this one is our delta T2. Now, it can be interchanged. Pwedeng ito yung delta T2 and delta T1. Basta, don't forget na ang kinoconsider natin difference is this HI and then CO. And then, lagi siyang H and C. Okay? Hindi siya pwedeng TH and then THO. So, this is for the temperature profile. And then, we do have this flow rate of water. So, we have the mass flow rate of water, which is 2 kilograms per second. And then, I think we have here the area, or the total area here would be 20 meters squared. And then we're asked to find the overall heat transfer coefficient U. Okay, so in your handout, as you can see here, flash ko ngayon. So, meron dito na description about the U and of course yung ating mga area. So, saan ba yun? Ito. In this case, we have UI and then UO. So, basically, yung UI nga na banggit ko before na with reference to dun sa inside and then yung UO is on the outside. So, pag kinonsider natin yung UI, the overall heat transfer coefficient is considering the area and on the inside, and then dun tayo mag-evaluate yung ating overall heat transfer coefficient. But what if this problem doesn't tell you about if it's if it really is on the inside or the outside. So basically, just write U or A for that. Ibig sabihin nito, hindi natin na-specify kung ano siya, but in this case, meron naman tayong formula or the general formula here that is UA and the delta T overall. So basically, that's the general equation that we'll be using instead. Okay, but of course, if it's UO and then A lang dito, so we know that most probably yung area na tinutukoy dito is on the outside. But if it is I for this U, then that's on the inside. But in this case, let's just use U and A since wala naman dito in-specify kung nasan siyang location ng ating area. And then, I think kompleto na yung ating mga given. So, we're asked to find U. So, we know that the formula here is simply, let me just use another color. So, this is Q is equal to UA and then TM. So, yung overall, i-represent ko lang siya as M. Kasi same lang din naman sila. This TM means that it is the mean temperature difference of our fluid. And we know before na kapag meron siyang double pipe and then counter current, diba, we know that TM is actually, or this is the MTD, mean temperature difference, that is equal to the correction factor times the log mean temperature difference. But in cases like this, when we know that the pipe is a double pipe and it is counter current, specific na siya sa isang flow lang, so we know that FT is equal to 1. So in this case, the mean temperature difference is simply the log mean temperature difference. So we can now rewrite this in terms of Q is equal to UA and then LMTD. Okay? So, and then knowing LMTD, pwede natin siyang kuhanin dito based sa ating temperatures, sa apat na temperatures. And then yung area natin is given. So, hinahanap natin itong U. But how about Q? So, based on our problem, wala ditong binigay sa atin na Q. So, paano ba natin siya madedetermine? But remember, the flow rate of water is already given here. That's 2 kg per second. So, diba, Q, we know by virtue of this heating na pag inabsorb nung ating equipment, yung heat na nag-exchange in between these two fluids, we know na nag-travel yung ating heat from the hotter region to the colder region, from the inside going outside. So in that case, the temperature that is, the heat that is being exchanged by water would equal to this expression, that is UA and then the log mean temperature difference. So therefore, ang ating Q is simply MCP average and then delta T for our equation here. So we can now equate this to UA and then LMTD. So ano ba yung ating gagamitin na mass flow rate? So that's for water, and that should be also equal to the heat exchange for our polymer. Pero since wala naman tayong mass flow rate ng polymer and then specific heat capacity ng polymer, so hindi natin siya pwedeng gamitin. Hindi rin natin naman kasi alam kung ano ba yung polymer na yon. Okay? So with this equation, we can now medyo umuulan ng malakas. So with this kind of equation, we know that we're already given by this M. So ito hinahanap natin. So A, L, M, T, D. So, di ba, pagka may hanap tayong isa, need natin na kailangan masigurado na meron tayo ng lahat. So, delta T is simply the change in temperature for the water. So, in this case, di ba, nag-start siya sa 90 and then ended up with 60. So, yun yung ating gagamitin. And then, we know that we need to find the specific heat capacity. So, in this case, we will be evaluating the specific heat capacity on the average or the bulk temperature of water. So in this case, the average temperature is simply equal to THI plus THO divided by 2, which makes this 90 plus 60 divided by 2. So the average temperature is, I think that's 75 degrees Celsius, which is equal to 348.15 Kelvin. Okay. So, in this case, dito natin i-evaluate ating CP. So, I have already interpolated that from our Paris handbook. So, alam niyo naman yan, ilang beses natin yung ginawa. So, the specific heat capacity is equal to 4,197.0258 joule per kilogram Kelvin. So, di ba yung unit natin is commonly joule per gram, knowing that it's around 4.184. But in cases like this, we know that yung watts natin, kasi yung ating U is expressed in watts. So that's this watts is actually a unit for power. So that's joule per second, and we need to incorporate joule for this case. And then kilogram kasi is yun yung ating MKS unit. So mag-a-agree siya dun sa ating meter. Okay, so let's substitute all of these from our equation. So we have now M, which is 2 kilograms per second, and then CP, which is 4,197.0258, that's joule per kilogram Kelvin. And then we have our delta T. So delta T is 90 and 60, so we have 90 degrees Celsius minus 60 degrees Celsius, and di natin need i-convert to Kelvin kasi siya ay difference. But if it's not, then kailangan natin siya i-convert. Then this is equal to U. Ano yung hinahanap natin? And then A. So the area is 20 meters squared. And then we check on the log mean temperature difference. So dito ko siya ilalagay, and then I'll separate that from here para mas magets niya. So log mean temperature difference natin when it's countercurrent double pipe. So that is always delta T1 minus delta T2 over ln of delta T1 over delta T2. So yun yung general niyang formula lagi sa any kind of flow. So in this case, we have delta T1 is THI and then TCO. So we have THI minus TCO and then minus THO minus TCI. And then, of course, ln of THI minus TCO over THO minus TCI. Okay? And then we substitute for all the values here. Yung ating inlet is 90, and then yung TCO natin is 50. So we have 90 minus 50, and then minus, yung ating outlet becomes 60, and then yung inlet natin is 10. Okay, so this one is 90 minus 50, and then 60 minus 10. Okay. So LMTD is equal to, when you're solving for this, don't forget to write the parentheses kasi baka magkamali kayo pagka hindi nyo siya nailagay. Okay. So ano ba yung unit natin dito? So we can use degrees Celsius for this. Okay. And also pwede rin naman siyang Kelvin kasi siya ay difference na ng temperature. So either way, it will give you the correct answer. So that's 44.8142. That's Kelvin. So i-banded natin itong hanapin. So area and then LMTD. So kompleto na yung ating mga necessary na hanapin, pero let's just cancel out some units here muna. Okay. So, in this case, we have joule. I'm sorry. This should be ito, and then itong Celsius dito. So, in this case, I have joule, Kelvin, and then meter squared. So, diba knowing na joule is actually Newton meter, so we'll be left out with the unit for U for this case. And then, this joule per second would give us the value which is in watts. So we have U is equal to 280.9618. That's watts per meter squared. And then we have Kelvin. So this is our final answer for this problem. Okay, so I hope medyo malinaw yon. Simple lang naman yung nangyari natin dito, no? We have Q is equal to UA mean temperature difference, and knowing that this is a double pipe countercurrent, So we need to employ this LMTD instead of just simply using any temperature difference. So you might be wondering bakit hindi nilang parang HA and delta T kasi before in convection, kasi dito kasi ang convection yung medyo nagpe-play ng vital role in our heat transfer. But hindi na lang kasi gamit natin yung H instead of having U and then this delta T. So, in heat exchanger, this is quite different dun sa ating mga normal indirect contact ng fluid natin. Kasi 'di ba before, meron din tayong mga pipes na meron nagfo-flow na fluid and then meron siyang exposed to another fluid pero convection na ginagamit natin. So the difference is that this heat exchanger has heat that varies to the location of with the location of the fluid. So ito kasi 'di ba, ang heat exchanger kasi continuous tube sila. So basically paghaba niya or as long as it moves towards the end of the tube, the temperature gradient becomes different. So kung makikita nyo dito, 'di ba? Ito actually hindi naman talaga siya yung difference dito, magkaiba naman siya dito. So basically nagbabago siya along the way and we need to incorporate those changes kaya na-arrive natin tong log mean temperature difference assuming na ito na yung average temperature difference nila doon sa mismong system ng ating equation. That's why we employ TM or log mean temperature difference instead of just simply taking the difference in between these two any fluid that we have. And of course, parang hindi rin naman siya practical na gamitin is any temperature difference lang dito knowing na there are two fluids that are involved in this process. So, you can do that by simply taking HI and then HO, yung difference nila, pero that's finding Q using the specific heat capacity or this, sensible heat that we have. And by the way, this one is, nasabi ko naman din kanina before, this should be equal to mCp delta T rin of the polymer. So, para in that case, we don't break any rule sa ating science or physics or chemistry. Okay? So, that's it for number 1. Now, let's move on with the other type, which is the shell and tube.